So last week I had a forecast for Italy and Spain. So quick reminder of what I have done. So looking at the total number of deaths in China, I noticed that the number of deaths follows a sigmoid curve. And this sigmoid curve actually matches a model I know from ordinary differential equations called logistic model. And I match a curve, which is a logistic curve, and I have tried to do the same thing, the same model, but with different parameters for Italy. So I've done that for Italy, and I came up with the fact that the number of total deaths will be 8,000. And then I've done the same thing for Spain, and I come up with this number of 3,800 deaths according to the logistic model. Today I'm using the same models, but I tune the parameters according to the new data I have available today, 29th of March. So some people ask me why did I model the number of deaths and not the number of affected people. That's easy because the number of affected people are actually unknown. You never know how many people carry the virus because we are in the impossibility of testing all people, and some people are asymptomatic or have some delayed symptoms. It's only the number of deaths which is an exact parameter, and we have access to this on the internet so far. The model is the same model like last week. It's a logistic model. This is a logistic model. It has the following parameters. X represents time here, measured in days. F of x is the number of deaths until time x. K is the maximum number of deaths or the capacity of the threshold of the model. C represents the virus propagation rate, and the D represents, it's a phase parameter or a delay parameter, as you will see later. Now, some people ask me why you didn't use a more complex model. Well, I actually like simplicity, and philosophically speaking, this is called Occam's razor. If you have two mathematical models modeling the same data, and one of them requires a smaller number of parameters than another, then you always have to choose the one which is the simplest, with the smallest number of parameters. In our case, the parameters I employed in the model are K, which models size, C, which models shape, and D, which models the delay, the time delay. So size of the model, the shape or the curvature of the model, and the time delay. I can't think of erasing from the model any of those three parameters. For instance, if I give up of the size, then whatever I have left here using shape and delay is just a delayed exponential model which shoots forever to infinity, and we don't have any maximum number of deaths. It's like something which is not realistic. In machine learning, this principle applies very often because using too many parameters, that leads to an overfit of data. So these models do not have enough capacity to generalize well to the new unseen data, but they work very well for the data you already have because it actually memorizes the data in the data table you have available. Okay, so the model we have has three parameters. I'm going to say a few words about each of these parameters to understand what they mean. K represents the maximum number of deaths, and it's proportional to the country's population or to the community's population, because this sigmoid model works for a population which is supposed to be isolated. And for instance, in Italy, it says that 10% of the affected people die of coronavirus. So K, in this case, is going to be a proportion of 10% of the total population of the community or city. The second parameter is D, which introduces a delay, a time delay in the model. So not all countries started at the same time, and not all of them will end the crisis at the same time. So the sooner it starts, the sooner it will end. For instance, here we have, as an example, China, which started in December and already reached the threshold like a week and a half ago. The last parameter is the shape or the curvature of the curve we are fitting through the data. So C is the rate at which the virus spreads. If you look at this equation here, you can see that C is a proportionality factor. Y represents the number of infected people. This is the rate, Y prime, the rate at which people get infected, and is proportional to the number of people which are infected multiplied by the number of people which are not infected. So this is the number of encounters between infected and not infected people. If people stay isolated at home, then C is equal to 0. So that's why the government wants us to stay home, because in that case C is 0, and if C is 0, Y prime actually vanishes, which means that C is a constant. Well, in reality, people don't stay home, they go to buy groceries and they go to the doctor or whatever, case in which C becomes larger than 0. A large value of C means that the sigmoid curve is more steep, which means that a larger rate of affected people will rush to hospitals. So the administration likes not many people to rush to hospital, so the hospitals can actually have enough capacity of treating people. So actually is delaying the number of people who get affected. But at the end, this C does not affect the number of the maximum number of dead people, which is K. They are independent parameters. So what I'm going to do today is to go on the report as of March 29, 2020, and notice that United States is on the first place with about 125,000, followed by Italy, China, and Spain. And I'm going to redo the same thing I've done last week for Italy and to make a comparison between my models. So whatever you see here in green color is the last week forecast, based on the data up to this point. So since last week we have more data which actually shoot far over the threshold I actually foreseen last week. So I need a new model to match the new data, which is still same model, but the parameters have to be tuned in a different way. So after tuning, we obtain this blue model, which is the sigmoid passing through all the red points, having the new forecast with a threshold at 15,800. So the new forecast for the number of deaths in Italy, it's about 16,000 right now, as of March 29, 2020. It's weird that this new forecast is double than the last week forecast, which actually shows how relative mathematical models can be in the case when you don't have enough available data. Now, the same thing has been done for Spain. The model you see here in green color, it's the model from last week when I said that 3,800 people are expected to die. You can see that in only 1 week, the number of deaths actually exceeded far the threshold I foreseen last week. And right now, the new model I constructed, it's the blue sigmoid curve, which passes through all the new data. So everything here is new data. You can see starting from this point all the way to 6,000. Comes with a new threshold of 9,800. So it's about 10,000 people, dead people in Spain in about 2 months. It's interesting that the ending time of the crisis is the same. You see here the dashed line passing through 2.5 months. 1 unit here means 1 month. So 2.5 is the same for both models. So both models reach a threshold after 2.5 months. So right now we are here, so all the way up to here it's about another 2 months. So it's 1 unit here, half unit here, and another half there. Well, after doing that for Spain and Italy, I would like to follow with the data for United States. Right now we have much more data than last week, so we should be able to make up a rough model. So the number of deaths in the United States so far as March 28, it's 2,220. And if you see here in red color, it's the I plotted the data for United States, you notice that this data, in comparison with Spain, this is the data from last week in Spain, is actually behind by 2 little squarelets here. So 2 little squarelets and a half means like 2 weeks. So United States, it's about 2 weeks behind Europe, actually behind Spain. So the red dots you can see here increase exponentially, so we are still in the very incipient stage. Now the next thing is to extrapolate this data to using a logistic model to find the threshold and to forecast the total number of deaths into the United States. So here it is. You can see that here is the model you have seen before. The model fits very relatively well and it shoots very high. It shoots a lot higher than all the other countries we've seen before. It shoots about 20,000. So the threshold is about 20,000. Well, I'm pretty sure this logistic model for United States fitting the available data as of today is not very accurate. So probably in a week or 2 or 3 weeks from now, I'll be able to provide a much better number here. But what I can actually say now that the forecast of 20K is accurate to an order of magnitude or something like that. So it's not an accurate by the number of, by the thousand, but by the order of magnitude. So we are expecting the number of deaths to be in tens of thousands.